Aberdeen Harbour was established in 1136 by King David I of Scotland. According to the Guinness Book of Business Records, it is the earliest founded business in Great Britain. In the early days, the harbour would have been used by local fishing boats and small coastal trading vessels, and by 1136, in the era of the Knights Templar and the Crusades, the bishops of Aberdeen had the right to levy a tithe on all ships trading in the port. By the 1500s, regular trade had been established with the Baltic ports, and several fortunes were made by well-known Aberdeen families such as Robert Gordon, he of Robert Gordon's College, and Provost Skene, he of Provost Skene's house in Broad Street, who were merchants in Danzig. Since its inception, the harbour has supported a fishing industry, which boomed with the introduction of the steam trawler in the 1880s. From the earliest times, right up to the 1970s, the port had a flourishing shipbuilding industry, and many well-known ships were built here, including the William, the first Scottish ship to sail to Newfoundland in 1596. The most famous ship, however, was the Thermopylae, a tea clipper built by Walter Hood for the Aberdeen White Star Line, which in 1872 famously beat the Clyde-built Cutty Sark in a race back to the UK from Shanghai. The Thermopylae won the race by 1 whole week.
The Aberdeen Steam Navigation Company was an offshoot of the Duffus shipyard and traded from 1821 until 1962. Their regular route was Aberdeen to Hull and London, carrying livestock, general cargo and passengers, but they occasionally went to other ports as far away as Hong Kong. Their ship, the City of London, was requisitioned during the Crimean War, and their ship, the City of Aberdeen, was wrecked on the Craigmorroin Skerry off Portlethen on the 20th of January 1871.
One of the stranger events occurred on July 1st, 1909, when thousands of people gathered at the port of Aberdeen to witness the world-famous escapologist Harry Houdini dive into the chilly water while chained and handcuffed. A cold and watery demise appeared inevitable for the man, but suddenly he resurfaced, triumphant and free from his shackles. Needless to say, his exploits ensured that his shows at the nearby Palace Theatre in Bridge Place were a huge success. In the 1800s, there were several shipbuilding firms, and William Duthie and Sons and Walter Hood of the Thermopylae fame were the two biggest. In the 1950s, there were still two major shipbuilding firms, Hall Russell & Co Limited, who traded from 1864 until 1992, and John Lewis & Sons, who traded from 1907 until 1976, and who built the sail training vessel Malcolm Miller in 1968. John Lewis & Sons were taken over by the Wood Group in 1972, who were then expanding into the oil service sector. From 1855, the Harbour Board ran their own tramway, initially with horse-drawn wagons, but later using steam and battery-powered locomotives. Before the Denburn Junction Railway was built in 1867, the Harbour Board tramway was the only link between the railways running north and south out of Aberdeen. It connected the Guild Street station on the South Railway to Waterloo Station, which was a branch from the North Railway at Kitty Brewster Station. The railway had three main customers: the gasworks in Cotton Street, the adjacent Sandilands Chemical Works, and the electricity works in Milburn Street. Trains carrying coal were a regular sight around the harbour quays and streets until 1977. The arrival of the offshore oil and gas industry in the mid-1960s, however, marked the start of a period of intense modernisation of the harbour, during which it was virtually rebuilt. It has now been transformed into one of the most modern ports in Europe. In 1661, at the time of Parson Gordon's map, the mouth of the River Dee was a shallow, muddy estuary. It is noted that the bar at the harbour mouth was almost completely exposed at low tide. Some development has taken place and the ground on the north side of the estuary has been raised above tidal levels and a quay built. The pack house had been erected in 1634 and was where cargo was weighed and custom dues and town dues were levied on food, coals and building materials. In 1773, at the time of George Taylor's map, at high tide the estuary would still have been a large uninterrupted sheet of water and would have been quite a sight, sort of like a miniature Montrose basin. We see that the pack house is now called the Weigh House, and a customs house and permanent fish market have been added, and there is now a crane on the pier. For the first time, a dockyard is recorded at Fitty, although shipbuilding is known to have been carried on here for at least the previous 300 years. 13 years later, in 1789, Alexander Milne's map shows that the number of dockyards in the Fitty area has rocketed from 1 to 6. The 1869 Ordnance Survey map shows that the first major development to the harbour has been completed, and the Upper and Victoria docks are recognisable today. The railway had arrived in 1854, and the dockside tramway is marked on the map. At this time, the Harbour Act authorised the harbour commissioners to divert the River Dee downstream from the suspension bridge into a new channel to the south. Here we see the diversion of the River Dee being carried out. In the centre of the picture is a temporary earth dam, with the River Dee on the left and the new hand-dug channel on the right. The 1888 Ordnance Survey map shows that the new Albert Dock has been formed in the old channel of the River Dee, and the river is now confined to its new channel. All of the ground to the north and west of the river has been reclaimed. Today, the Harbour Board is not content to rest on its laurels and is marching boldly into the 21st century by expanding its facilities into the Bay of Nigg. In times past, the Bay of Nigg was a popular recreational area for people who lived in Torry. It was a great place for a Sunday walk or for a picnic. More recently, it had become the principal surfing location in the Aberdeen area. Not anymore. Aberdeen Harbour Board intend to stop all of that nonsense. In 2017, they embarked on an expansion of their docking facilities into the Bay of Nigg in what is now a £400 million project. The new harbour is referred to as Aberdeen South Harbour. The South Harbour will add 1.4 kilometres of quays to the 4.5 kilometres of quays already available in Aberdeen North Harbour. The maximum water depth will increase from 8.5 metres in the North Harbour to 10.5 metres in the South Harbour.
Let us start by looking at how harbours used to be built. The picture shows a cofferdam for a bridge pier. As you can see, it provides a large waterproof hole in the water, down which men and machines can work to create large concrete structures. The traditional way to build harbour quays is to surround the whole quay with a cofferdam like this, and to fill it with vast amounts of concrete to create the structure of the quay. In the picture, the areas coloured purple are the cofferdam, which is normally sheet steel piling. For the new South Harbour, about 4 kilometres of cofferdam would be required to surround all of the quays to allow construction to happen, which is an awful lot of cofferdam, which would be extremely expensive. Inside the cofferdam, a timber shutter would be constructed, which is filled with concrete to make the harbour walls. The shutter is the areas coloured yellow and brown in the picture. The shutter would then be filled with concrete, coloured blue in the picture, to form the harbour walls. All of this work has to be carried out on a muddy building site, continuously lashed by rain, sleet, snow, frost and rough seas. Let us now look at how modern engineering has changed all of that. Suppose instead you could precast all of your concrete in a nice big sheltered shed, with no rain, sleet, snow, frost or rough seas to bother you. Then you just drop the large chunks of precast concrete that you have made straight into the water to create your harbour quays, which is much quicker and easier. This is the innovative approach used in the construction of all modern harbours. The large chunks of precast concrete are called caissons and acropods, but more about them later.
The names used for the various parts of the harbour are shown on the site plan. Note that everything is either a quay or a breakwater with a prefix of north, east, south or west. It is perhaps slightly confusing that the north breakwater and the east quay are part of the same structure. The harbour faces of all of the sheltered quays are formed by precast concrete caissons. The caissons are large concrete boxes with an open top and internal baffle walls. They are 50 metres long, 15 metres wide and 16 metres high, the size of a 4-storey block of flats. The west end of the harbour will be affected by the rebound of waves coming down the channel and reflecting off the south shore. If the quays at the west end of the harbour were built using caissons, then the vertical face of the caissons would reflect the rebound waves into the sheltered eastern part of the harbour. On the other hand, if you let a wave run up a beach, it will lose half its energy. So the western part of the harbour is designed with sloping beaches, and the quays above are formed by a cantilevered concrete deck supported on concrete columns. The seaward faces of all breakwaters are faced with acropods, which vary from 20 to 40 tonnes in weight. The acropods are designed to break up and dissipate the energy of the waves. Aberdeen Harbour Board issued a proposed design for the harbour to the tenderers as shown in the drawing. The idea behind this design is that any waves that manage to overtop the breakwater will be carried away in the channel behind it. The tenderers were invited to submit any improvements to this design along with their offer, and any improvements would be taken into account when awarding the contract. For this very large design and build contract, Dragados, a Spanish international construction company, were in partnership with OV Arup, an international firm of civil engineers. OV Arup made a dynamic 3D computer model of the proposed harbour to experiment on with ideas for the construction. When something interesting was found in the computer model, The result was tested on this 1:60 scale physical model of the harbour, built in a warehouse near London. Dragados and Novi Arup submitted a revised design for the East Quay and North Breakwater, as shown in the bottom half of the drawing, which gave approximately 10 metres of additional width to the East Quay. This design change was accepted by the Harbour Board, and Dragados were awarded the contract. With the hindsight of having seen the waves just about overtopping the sea wall, it appears that it was a very wise choice not to go for the original low-level breakwater design. There are three aspects of the design that are worthy of note. The first aspect is that the whole of the finished structure will be saturated with seawater, and the tide will rise and fall not only in the water in the harbour, but also within the structure of the quays and breakwaters. However, the movement of water through the structure is controlled, as it has to pass through successive layers of finer and finer materials. The second aspect is that large parts of the structure have been prefabricated off-site, including the caissons, suspended deck and the acropods. All of these components are simply brought to the site and dropped into place. There is no need for any cofferdams, and the use of large volumes of in-situ concrete was greatly reduced. The third aspect concerns the staggering quantities of material used in the construction. 770,000 tonnes of precast concrete and 165,000 tonnes of in-situ concrete give a total of 935,000 tonnes of concrete. The 2,400,000 cubic metres of material dredged from the seabed is also a quite extraordinary number. The north side of the Bay of Nigg in May 2017, before construction work commenced. The south side of the Bay of Nigg before construction work commenced. The back of the Bay of Nigg before construction work commenced. The contractor beginning to get established on a site at the back of the bay. The two white lines across the picture are the top edge of bubble curtains, which are created by a bank of 10 compressors driving air through two 850-metre long perforated hoses, which lie on the seabed across the mouth of the bay. The bubble curtains attenuate the passage of sound through the water, thereby limiting the effect of construction noise on marine life in the area. The North Breakwater is just beginning to push out into the Bay of Nigg. You can see the acropods in the centre and front right of the storage yard. This is a section through the North Breakwater and East Quay which shows the details of construction. The core fill material is protected by the rock armour, a layer of very large rocks. On top of the rock armour is a layer of acropods. Here we can see the layers of material that make up the breakwater. The pink material on the level part of the breakwater is the core fill material. On the sloping faces we can see the rock armour, a layer of large stones tightly packed together. The outer layer of acropods is being formed on top of the rock armour. The acropods are not carefully aligned. They are left just as they lie when released from the crane. However, the gap between the acropods has to be exact to allow the correct amount of water to pass between them. A temporary building was erected at the south end of the site to manufacture the 9,000 acropods required to clad the seaward faces of the breakwaters. Inside this building is housed an automated carousel production line. Here we see an acropod being released from its steel mould. The finished acropod at the end of the line. In the background you can see large steel moulds at the start of the production line. Note the figure in the bottom left to give you the scale. The field adjacent to the temporary building was levelled as a storage area and is quickly filling up with acropods. Eventually, every spare inch of space on the site will be covered by acropods. The site shut down over the winter, so there is not much progress since last autumn. By July, the North Breakwater is pushing further out into the bay and dredging operations are underway, which will continue relentlessly for the next 3 years. The works seem to be standing up to their first test. Here we see the results of last year's work with the North Breakwater well out into the bay. The process starts with an empty barge and a caisson construction rig which contains a movable floor. Build a reinforcement cage on the barge. Float the barge into the caisson construction rig. Suspend the reinforcement cage and remove the barge. Raise the movable floor to just above water level. Build a shutter round the reinforcement cage. Start building a new reinforcement cage on the barge. Pour the first lift of concrete. Lower the movable floor by 1/3 of the height of the shutter. Continue building the reinforcement cage on the barge. Pour the second lift of concrete. Lower the movable floor by another 1/3 of the height of the shutter. Complete building the reinforcement cage on the barge. Pour the third lift of concrete. Lower the movable floor to leave the caisson floating. Tow the caisson away to a mooring. Move the barge into the caisson construction rig to start the next cycle. Looking down on the caisson construction rig and its attendant barge at the port of A Coruña in northwest Spain. The reinforcement cages being built on the floating barge. The barge is then towed into the construction rig. The reinforcement cage is suspended and the barge removed. The movable floor is raised to just above water level. Towing the completed caisson out of the construction rig. The heavy lift semi-submersible ship Blue Marlin arrives at A Coruña. The ship is submerged overnight at the rate of 1 metre per hour until its main deck is below the water level. And the next morning it is ready for the caissons to be towed over it. setting sail for the Cromarty Firth. The 1,080-mile journey will take 3.5 days. The Blue Marlin arriving in the Cromarty Firth. Towing the caissons off the now semi-submerged ship. The caissons moored in the Cromarty Firth. A single caisson at its mooring. The caissons were towed from the Cromarty Firth to Aberdeen one at a time, the first caisson arriving in Aberdeen. The caissons are like icebergs. 2/3 of them lie below the surface. One of the remarkable sights was to see the caissons being sunk to the seabed because they all lined up perfectly straight and level with no adjustment being necessary. This was achieved by having a perfectly level gravel bed for the caissons to lie on. Preparing to sink the first caisson to the seabed. The caissons are initially sunk by pumping them full of seawater. Later, the seawater will be replaced by filling the caissons with rock and/or dredged material. The north breakwater clad in its winter defences while the site is shut down. The rectangular concrete blocks covering the top of the breakwater are temporary protection. The north breakwater after the beast from the east. The concrete blocks at the outer end of the breakwater are scattered like confetti. However, inshore, where they are protected by the acropods, they remain intact. 5 caissons now in place and sunk to the seabed. The intensive dredging continues and ultimately 2.4 million cubic metres of material will be removed from the seabed. Filling the caissons with dredged material. Starting to create the east quay by filling the void between the caissons and the north breakwater. Filling the void between the caissons and the north breakwater continues.
The self-unloading ship will have a series of holds that are separated by bulkheads. Under the holds is a tunnel which runs along the bottom of the ship. In the bottom of each hold there are 2 openings, one on the port and one on the starboard side, under which run 2 conveyor belts in the tunnel. The holes in the base of the holds have hydraulically operated doors, which when opened allow the aggregate to drop onto the 2 tunnel conveyor belts below. Aggregate flowing onto the 2 tunnel conveyor belts makes its way to the stern of the vessel. A smaller pair of transverse conveyors directs the flow to the centre of the ship. The aggregate then enters the sea loop elevator, which has an inner and an outer belt. The speed of the belts is synchronised so that material entering at the bottom is sandwiched between the 2 belts and is carried up to the top of a tower above the deck. The aggregate leaves the top of the tower and drops onto the boom conveyor, which transports the aggregate to the very end of the boom, where it drops onto the ground.
A self-discharging aggregate carrier unloads its cargo of gravel from Norway. Much of the rock used on the project came from Blackhill's quarry just south of Cove, but the requirement was so vast that some of it came from Norway. This ship carries 35,000 tonnes of aggregate, and she made 7 trips to Nigg harbour, with all of the aggregate going into the East Quay. An extensive area of fill is now complete on the East Quay, and the space is immediately used to store acropods. Throughout the project there was always huge pressure to find space to store all of the rock and precast concrete units required for the works. Goliath, one of the 2 largest dredgers in the world, has a bucket capacity of 40 cubic metres, and it can dredge to a depth of 26 metres. Goliath at work at the West Quay. There was a lot of rock to be removed from the seabed, which Goliath did without the use of any blasting. The yellow crane-like things are piling rigs, drilling the holes for the columns to support the suspended deck on the North Quay. Behind the red ship we can see a newly arrived caisson being prepared to be sunk to the seabed. Here we see the thin line of caissons forming the front face of the quays. The quays seem to go on and on and on forever. The arrows highlight a reinforcement cage being lowered into the steel tube, which lines the hole made by the piling rig. The length of the reinforcement cage gives you some idea of the depth of the hole. Once the reinforcement cage is lowered to the bottom of the hole, it will be filled with concrete. Note that the piling mat, a flat layer of rock to allow the machines to operate, extends outwards into the harbour beyond the piles. Later, all of the rock piling mat will have to be removed to leave the piles standing in the water. In the face of a forecast storm last year, a lot of material was hurriedly placed to protect the works. Aberdeen Harbour Board required this material to be removed and replaced, hence the gap in the acropods on the seaward face of the North Breakwater. All of the caissons from the North Quay are now in place. The yellow crane-like piling rigs are working on the West Quay to provide the supports for the suspended deck. A start being made to the construction of the South Breakwater, an effort that was quickly abandoned. This work will not eventually restart until May 2021. Despite the inclement weather, the work of moving fill material continued. The foundation of the seawall. In preparing to start the construction of the seawall, the first step is to lay a level concrete foundation. The 2 lines of piles for the West Quay, which will eventually support the suspended deck. There is a profusion of piles, Some of these must be defective and have been replaced by a new adjacent pile. The infill on the East Quay is progressing. Disputes in the construction industry are never settled amicably. There is too much money involved to allow that to happen. However, this contract was an exception. Aberdeen Harbour Board and Dragados mutually agreed to end their contract. Dragados thought the Harbour Board were a very demanding client, and the Harbour Board thought that Dragados were a very slow contractor. It is true that once Dragados departed, the work moved into a higher gear. We can see that the ongoing struggle to find space to store materials has not been resolved. We can see why the seawall still needs to be higher. The small concrete tank is a housing for pumps to supply fresh seawater to the live fish tanks in the marine lab. The foundation for the seawall is getting closer. And the major fill behind the caissons in the North Quay is underway. The sloping beach below the suspended deck on the West Quay is covered with a neat layer of stones. Placing the stones with the aid of an underwater camera. The foundation to the seawall is complete. And the major fill behind the caissons on the North Quay is progressing. Both of these contractors will complete their allotted tasks before the end of this year. The base for the seawall is about 1.6 metres thick and has two channels on its upper surface to provide a quay for the concrete in the first lift. The base for the seawall is nearing completion. The overall height of the seawall is 11 metres and 2/3 of that is provided by the first lift. This is the formwork for the first section of the first lift of the seawall. The formwork for the second section of the first lift of the seawall is also now in place. Two rock-carrying ships are just finished discharging their 5,000-ton cargo of rocks. There is now a vast amount of rock stored on the site in preparation for building the south breakwater. The first lift of the seawall is progressing. In the background, the south breakwater is starting to push out into the North Sea. The start of preparatory work for casting the edge beam on top of the caissons. The seawall is looking good. Note caisson J20 tied to the East Quay while waiting to be sunk as part of the South Quay. Also notice that the caisson is named Diane. It became a tradition that each caisson was named after the most recent addition to the family of one of the workers on the site. So we have caissons called Stanley, Jeanette, Katrina, Gary, Brenda, Christine F., Holmes, Adelaida, Martine, Louise, Shirley, Jill, Kirsty Edith, Carla, Lucy, Eve Isabella and Sally. Another boatload of rock arrives from Norway. The South Breakwater is now well out into the North Sea, but it is clad with rock armour only. The second lift of the seawall brings it up to its full height of 11 metres. The formwork has been erected for several sections of the second lift of the seawall. In the background we can see that the outer half of the South Breakwater is now clad with acropods. The seawall in the North Breakwater is now complete. Now that the South Breakwater is complete, it has used up all of the rock and acropods and the site looks remarkably uncluttered. Permanent steel formwork to form the harbour face of the edge beam on top of the caissons. Permanent steel formwork is installed between the yellow arrows. Filling the void between the acropods and the seawall has started. The pile of rock on the quay is what will be used to complete filling the void. The completed South Breakwater, a foreshortened view caused by the use of a telephoto lens. The South Quay is formed entirely from caissons. A concrete service duct carries water, electricity and fuel lines to each individual berth. Constructing the service duct down the centre of the North Quay. A branch duct runs out to the quay edge at each berth to deliver the services close to the vessel. Building the reinforcement cage at a junction with a branch duct. The reinforcement cage is complete. It is now being enclosed in timber shuttering. The concrete edge beam is complete on the East Quay and on part of the North Quay. Most of the service duct running down the centre of the North Quay now has a concrete cover. Erecting the formwork for the concrete edge beam. The back of the permanent steel formwork on the face of the concrete edge beam. The seaward face of the North Breakwater is now complete.
Except that they ran out of acropods. Unfortunately, the 9,000 acropods that were manufactured were not quite enough to complete the job. You can see that within the area enclosed by the yellow line, the rock armour is exposed, and it's going to stay that way. This is the view from the other side, where even more of the rock armour has been left exposed.
The pink areas are part of a giant precast concrete Lego set, with the pieces bonded together by in situ concrete. The precast concrete U-beam is hollow, with holes in the bottom to allow the reinforcement in the piles to enter the beam. The whole structure of pile caps, U-beams and Y-beams are all bonded together with in situ concrete. The hollow U-beam is placed on the pile caps. The nearest U-beam is being filled with concrete by a concrete pump. The 3 U-beams in the background have already been filled. Delivery of a load of Y-beams. The lattice of the main U-beams and the lateral Y-beams is taking shape. They have started laying the precast concrete cover planks on top of the Y-beams, and each of the 4 bays on the right-hand side has a strip of cover planks down its right-hand side. A view of the suspended deck from the harbour side. Laying the reinforcement at the heavy lift area on the east quay. The finished concrete paving to the east quay covers more than half the width of the quay. On the north quay, the edge beam and duct are nearly complete. An aerial view of the works which now have their final form. The only missing part is the suspended deck on the west and north quays. The service duct on the east quay. The service duct and paving on the east quay. The Harbour Board are now using the east quay for commercial traffic. Here we have 2 large piles of timber waiting to be shipped away. Finished concrete paving progressing well on the north quay. The finished concrete paving to the surface of the suspended deck is also progressing well. The first U-beam is installed for the suspended deck on the west quay. A ship arrives to remove the stack of timber on the east quay. The east quay on the 9th of November, with the finished concrete surface extending beyond the duct. The fill on the north quay beyond the duct continues. The finished concrete paving is complete on the outer half of the south quay. Work on the suspended deck progressing up the west quay. Nigg Bay has a long association with outfall sewers serving the city of Aberdeen. Indeed, the passengers on cruise ships berthed at the West Quay will have a superb view of the treatment plant for the modern deep-sea outfall sewer. The original outfall sewer to serve the city of Aberdeen started in Woodside, ran through Tilly Drone, crossed King Street at St Machars Drive and ran across the Queen's Links to discharge into the harbour next to the Roundhouse. In 1858, the Girdleness outfall sewer was completed, which started in Skene Street, ran down through Ferry Hill and along the north bank of the River Dee to Point Law, where it passed under the river using a siphon. It then went through Balnagask Hill in a tunnel and ran along the north side of the Bay of Nigg to discharge into the sea at Girdleness. In order to prevent any possible damage to the Girdleness sewer, either during the construction of the new harbour or by subsequent heavy harbour traffic, the 162-year-old sewer was protected by the curved, reinforced concrete slab seen in the photograph. Another view of the sewer protection slab. The twin weathered brick towers in the bottom left are old manhole access points to the sewer. The twin towers just right of centre are also manhole access points to the Girdleness sewer. The breakwaters doing their job. However, you would get a wee bit wet if you walked up the East Quay. The finished concrete paving completed on the South Quay. Note the caisson called Stanley. The suspended deck progressing up the West Quay. The end caps have been fitted to some of the U-beams on the North Quay. There is another line of Y-beams to be placed between the end caps to form the front edge of the quay. So here is the state of play on the 28th of December as we come to the end of year 6 of the project. The harbour is now being well used to accommodate vessels.
The fill on the North Quay progresses. On the West Quay, all of the U-beams and most of the Y-beams are now in place. At the far end, a small area of finished concrete paving is complete. In diagrams 1, 2 and 3, the brown line at the top is ground level and the brown line at the bottom is the load-bearing strata, which may be rock or compacted gravel. All of the piles will have a steel reinforcement cage inside them, which is not shown in these diagrams. Diagram 1 shows a hole for a pile drilled in good firm self-supporting ground, where the walls of the hole will not collapse when the hole is filled with concrete. A short length of steel lining tube may be inserted at the top of the hole to help keep the hole clean. Diagram 2 shows a hole for a pile drilled in loose, soft or wet ground, where there is a risk that the walls of the hole may collapse before or while the concrete is being poured. In this scenario, the expensive steel lining tube goes all the way to the bottom of the hole. Diagram 3 is a scenario where it has been decided not to line the full depth of the hole, but the engineer is not comfortable with that decision, which is what happened at Nigg Harbour. To allow the engineer to check the structural integrity of the finished pile, 4 small diameter tubes are inserted into the full depth of the pile before it is filled with concrete. This is preparatory work for a process called sonic logging. Diagram 4 shows a transmitter and a receiver being lowered at the same rate down a pair of the small tubes. The signal from the transmitter is carried strongly through the solid concrete, and the graph produced will be a level solid line. However, if there is a void in the concrete, as shown in diagram 3, the signal received will be very weak at the void because it does not travel well through air, and there will be a dip in the graph, as shown in diagram 5. The sonic logging process gives an accurate depth at which the void has occurred. The transmitter and receiver are lowered down each different pair of holes, as shown in diagram 6, which will give us 6 different graphs, which, when combined, show the full extent of the void in the pile. To remedy any defect, a tube is driven down the side of the pile to the exact depth of the void given by the sonic logging process, and concrete is pumped down this tube to fill the void. The testing process can then be repeated to ensure that the remedial work has completely filled the void. This photograph shows the West Quay, and the 2 gaps in the beams for the concrete suspended deck are places where remedial work is still being carried out on defective piles. It is thought that this damage was caused by water moving within the structure and washing out the wet concrete before it had time to harden. On the North Quay, all of the U-beams have their end caps fitted, and the Y-beams forming the front edge of the quay are also complete. The yellow and black buffers for the ships to bump against have been fitted to the end caps. The Noble Innovator jack-up rig arrives to undergo its 5-yearly maintenance check, which will take between 60 and 90 days. Over the next 3 months, there were 3 or 4 other jack-up rigs paid a visit to the harbour. In current times, these are associated with decommissioning work in the North Sea. These are the berth bookings for cruise ships in 2023. The Ada Ora was the first cruise ship to visit the new harbour.
the Nigg Harbour is in itself a major infrastructure project. It is only a small part of the Aberdeen Harbour Board's ambitious plans to develop both the harbour and its hinterland. The Harbour Board sees the North and South Harbours as nationally important infrastructure and a key economic driver and catalyst for growth. In order to realise its ambitions, it has its eye on the adjoining land, and as you can see from these maps taken from its strategy document, its long-term plan is to develop the Balnagas golf course area. A large chunk of St Fittock's Country Park, the whole of the Ness landfill site, and the strip of land between the railway line and Alton's industrial estate. This is another plan taken from the Harbour Board strategy document, showing potential development of the North Harbour. You may be forgiven if you think that somebody took some random buzzwords and dropped them onto a plan. Aberdeen Harbour has the potential to become a declining economic asset with the gradual rundown of the oil industry, something that the Harbour Board is anxious to avoid. One can only hope that in the future the Harbour Board's ambitious plans do not turn into a black hole.